Welcome back. We are closing this lesson now, and I feel I must go back to my question of electric field, the net electric field strength there, and how do I do that? I'm going back here. I want to help you do it. Look, this one is positive. Remember, the electric field is going outwards there, like that. Remember those drawings? So it's going outwards. We can work it out here. So this is going to be what? It's going to be 9 by 10 to the power 9 times 4 by 10 to the power minus 6, okay, which is that 3600 divided by 60 to exponent minus 2 times 60 to exponent minus 2. Don't want to make any mess there. So this is 0.36. That will be equal to, so you've got 36,000 divided by 0.36, and what do you get? You've got 100,000, which is 1 by 10 to the power 1, 2, 3, 4, 5 to the power 5 to the power 5 newtons, volt per meter. Let me just put it that way, volt per meter. This is the unit of electric field strength, and I'm going to show you where it comes from later on. Okay, now the same thing here, you work it out. This, remember, it's pushing there away. Now this one will be coming in, it's negative. Now let's see what happens here. It's going to be 9 by 10 to the 9 times 6 by 10 to the power minus 6. And what do we get? That's 54,000. You divide that by, this time here, it's going to be, in fact, here we made a mess up here. This mustn't be 60. This distance here is actually 20. So this will be 20. So good, I saw it before we finish off our lesson here. So 20 times 10, 20 by 10 to the power minus 2. What is that answer? That is 0.2. Okay, and that will be equal to 54,000 divided by 0.2, and the answer is 270,000, which will be 2.7 by 10 to the power 5 volt per meter. Now that comes from uniform field. I'll explain it later on. I hope I have time to do that. Now the net is what they want. Electric field net should be equal to, okay, should be equal to this one that takes it away minus that one that brings it in. So let's just work it out. This will be minus, of course. Okay, so let's say it's going to be minus 2.7 by 10 to the power 5. You add them together. This is going to be 1 by 10 to the power 5. And what will this be? This is going to be minus 1.7 by 10 to the power 5 volts per meter. Okay, volts per meter. And if you look at E equals F over Q, you would say the unit of measurement is Newton per coulomb. But then the acceptable one is volt per meter from electric field given by volt divided by distance for uniform fields in parallel plates. Okay, in parallel plates like this. So if you've got parallel plates like that, you've got uniform field like that. That's where it comes from, where this is D, and then you can apply potential difference there. So that is where the unit volt per meter comes from, and when we're talking uniform charges there, uniform field there, which is actually a field between two parallel plates that are charged. Okay, now hope you understood that. Now let's come back to this one here. The spheres are now brought into contact with each other and then returned to their original positions. Now calculate the potential energy of the system of the two charges. Now look at this. One thing that we need to know is that when they are brought to each other, the charge is now spread evenly. So we need to get the charge after they have been separated. So it would mean that the charge on them after they have separated. So let's get the charge first, the total charge first. It will be Q1 plus Q2. That will be 4 by 10 to minus 6 plus minus 6 by 10 to minus 6. So at the end you will have 4 minus 6, which will be minus 2 by 10 to minus 6. So each sphere will be having, that will be the net charge, the total charge. But then each sphere, okay, because that's when they are together now. You separate them. When you separate them, it means charge on each sphere is going to be Q1 plus Q2 over 2. And that will be minus 2 by 10 to minus 6, because that's your Q1 plus Q2 divided by 2. So charge on each sphere is going to be minus 1 by 10 to minus 6 coulombs. Now, the potential energy in this system, U, will be K Q1 Q2 over R. Remember, it's not R squared. So you substitute there, and then you say 1 minus 1 by 10 to minus 6, and of course there are 2 there, and you divide by the distance between them, 40 by 10 to minus 2. Okay, and then you find that. That's it. That brings us to the end of today's lesson. Hope you enjoyed it, and it's from me, Tinyiko Kosa. I'm signing out. Bye-bye.